All right, can anyone hear me? Throw something in the chat. All right. If anybody out there is listening. Perfect. So this is Schulich Ignite, session number 5. Hello everybody, Dark Soul Eric Lee. So again, obviously feel free to talk in the YouTube chat, but we do encourage everybody to go over to the Discord and talk in the general chat of the Discord, and you can ask for help from mentors there, and it's a really good place to be able to throw up screenshots and paste code in there. So it's a really great tool. Are all the mentors online at the moment? I believe we have, looks like nine or 10 mentors online, plus myself. So we've got a lot of mentors online on Discord right now. Throughout the lecture, we're going to have, to get people to be more engaged, we're going to have little challenge questions. And if you answer a challenge question on the Discord correctly, we're going to be giving out Ignite points. There's going to be somebody on the Discord keeping track of that. And Ignite points are for something mysterious at the end. You'll get a little bit of a prize or something at the end of the lectures. We'll keep track, and there'll be some sort of award with the Ignite points for answering questions, kind of like the sumo dolls we had. So, session overview. So last time we did loops and lists. So here we're going to be expanding more on loops. We're going to have for loops, while loops. We're going to talk about getting inputs. That would be like getting inputs from the keyboard. And we'll have a lot of examples at the end. So let's just jump straight into it with more loops. So what is range? Range is something like rectangle or circle. It's one of these functions that processing has already written for us that we can access. Now, instead of drawing something on the thing like rectangle draws a rectangle or circle draws a circle, it gives you back a list. So range is a list of numbers from 0 to 1 less than the number you give it. So for example, if we ask for range 9, it'll return a list going from 0 up to 8. Remember, we don't actually get 9 because lists always start at 0. So we've actually got 9 numbers here because we have it starting at 0. Now this kind of seems like it's a useless thing to do because we're just getting a list of a bunch of numbers back, but it actually comes in handy later on. Oops, 1 second. Sorry about that. Let me just get these slides back up. Sorry, bear with me for a moment. And should be back up now. Okay, sorry about that. So let's do this. So range is very convenient if we want to repeat code. It's very useful when you use it with loops. For example, if we wanted to just print hi, 6 times, we could do this. Now this seems very abstract as to how this would be useful, but let's try that out. So we always start with def setup, and in our def setup we always do size and we do background, but we're not going to be using the drawing functions. We're just going to be printing stuff out. So if we try and do our for loops, just like here, for, we'll pick a variable I in range, and we'll do 6. Now if we print out high, we should get this loop going through 6 times, because it goes through once for each value in the list that range gives us back. So we go through one loop for each element in here. Now we don't actually use any of these elements, but when we run it, we get high printed out 6 times. And if we replace it with I, we should get 0, 1, 2, 3 all the way through 5, but not 6, printed out to the screen here. Because I gets each value from this list one after the other, and it gets repeated for each value. Okay. Is there an attendance we should sign in? I signed the one last week. If you go onto the Discord, there'll be instructions about filling out attendance. So go check out the Discord server, and there's a link to a Google form on the Discord server. Now, if we go back to our slides here, using range with loops and multiple lists. So, if we have multiple lists that we need to deal with, using range is a great way to do them. And what I mean by that is, let's say we have a list that keeps track of our circles and a list that keeps track of the sizes of those circles. Well, which list do you use for your loop? Well, you don't use either of them. You just use range to go through the size of the lists. And if we see here, we have lists, they're both size 4. So instead of picking one of these lists and then we have to remember which one I is, just have I be a range of size 4, and then I gives you an index 0, 1, 2, 3, and then you can use that index to access each of these. So how do we use it? Remember the dartboard example from last time? What if we needed to color each of these individual pieces? So what we could do is set our RGB values. Sorry, we're not setting our RGB values. This R is a red color, this G is a green color, and this B is a blue color. And then we have all the sizes of these circles. And then we just have another list called colors, and we just assign a random color, one of these, to each of these. And then when we go through this, I is going to have each value from 0 up to 7, remember, not 8. And then that will give us an index to access each of these elements in turn. If you remember from last time, if we have a list, you can call it whatever you want. We're going to call it my list. And we set it equal to, I don't know, 45. We'll just put some random numbers in. And then I want to access this one. I have to go print, and I'll go my list at 0, 1, 2, and I'll print that out. Set object is unscriptable. What did I do wrong here? Print my list at 2. Oh, right. It's got to be square brackets. Oh my god, even the mentors are correcting me. The mentees are correcting me. So it's got to be square brackets. So if I print this out, I get 123. So if I wanted to print each of them in the correct order, I would have to manually go through and replace each of these with 0, 1, 2 up to the last index. But because this range gives me an I value that has the value 0, 1, 2, 3, 4 up to 7, I can replace this with just I. And obviously if I have this inside of a for loop up here, then this I value will get each value 0 through whatever I give it in turn. So it makes my life a lot easier. So we're going to move on to while loops. We're going to come back to for loops again, and we'll see why it's so helpful to have that. But another kind of loop is a while loop. Now, for loops, what for loops do is, if we do another example here, range 5, and I need a colon there, and we print hello. Obviously, we just get it printed out 5 times. And just like we did before, if we print out I goes from 0 to 4. So for loops are very helpful when you need to do a very linear thing. You just need to repeat code a certain number of times to get, every element of a list printed out, like if you need to print all 5 elements of a list. While loops are used for something different. With a while loop, you loop as long as a condition is true, which means you're not necessarily sure how many times you're going to loop for. In a for loop, you're going to repeat the code 5 times. But in a while loop, if you have while some condition equals true, you're not sure how many times you're going to loop through before this becomes, before this condition turns false, and then it skips out of the loop. So a good way to think about it is a while loop works kind of like a repeating if statement. So if we have if, up here we're going to do just a Boolean x, and we're going to say true. We'll just say it's true. And here, if x equals true, then we're going to print hello, or we're going to print if, just to say we're in the if statement. And then down here, if we do a basic while loop, if we do while x equals true, and then we're going to print out a little message saying that we're in the while loop, what's going to happen is we're going to set up our variable. All of this has to be indented because we're inside def setup. So you see, we get this while printing out constantly because we're stuck inside this while loop, because while is always equal to true, and x never changes to false, so it never jumps out. But we had one if printed out at the very beginning. So if I run this and then stop it right after, I stopped it too soon, and I stop it really quick, and then I scroll up all the way to the top. Ooh, I still let it run too long. My computer is lagging too much because of all this streaming software. Well, you're just going to have to trust me that if I was able to stop it right after I hit run, I would get one statement right at the top that said if, because that's this one, and then you would get whiles printed out infinitely afterwards. So this is why we say whiles are kind of like repeating if statements, is that this code will only run if this is true, but while this is true, it continues to run over and over and over again. And like I said, as long as the expression that we put inside the brackets is true, the code will continue to be repeated. But as soon as it's wrong once, it'll exit the loop and it won't go back into it. So here's a bit of a challenge, is if I have a loop, if I have a for loop that goes through 10 times, and let's just print out the value of I. We all know what's going to happen here. We just get 0 through 9. Let's try and recreate a for loop using a while loop. Okay, so think about how we might do that. We have to recreate a for loop using a while loop. So obviously we're going to start out with a while loop. So kind of what we want to happen here is we need to keep track of a variable, and in here we need to check, have we looped 10 times? And if we have looped 10 times, we want this to be false, and then we want to exit. So we want to check to see if we've looped 10 times, if that's true. So we're going to have to keep track of how many times we've gone through the loop. So let's do another variable. We'll keep with I. In programming, we tend to use the letter I for keeping track of loops. I'm not sure why, it's just sort of a tradition. So we'll start it out at 0, and we only want to go through this loop if I, which is keeping track of how many times we've looped, if I is less than 10. So if I is less than 10, that means we haven't gone through the loop 10 times. And while we're in the loop, we need to use I to keep track. So every time we end our loop, we increment I by 1. So every time we go through the loop, I increments by 1, and it effectively keeps track of how many times we've gone through a loop. Now, if we wanted to recreate our for loop, we just print I here. So we're actually using I to print out these numbers, and we're also using it, thank you, I++ is, that's something in another language that I forgot about. It has to be I plus equals 1. So we're using I to print out numbers 0 through 9, and we're also using it to keep track of how many times we've gone through the loop. So eventually, we should get the same behavior down here. On this last one, we print out 9, I plus equals 1, I goes to 10, And then this here becomes I is 10 less than 10. That's what we get in this statement on the last iteration. And 10 is less than 10 is obviously not true. That's false. And once this expression inside the brackets becomes false, we exit the loop. Okay, so some of you might be asking, what's the difference between a while loop and a for loop? If you can recreate one using the other, what's the point? Well, while loops, I would never use a while loop like this. Obviously, I would just use a for loop. It's a lot cleaner, it's a lot nicer to look at. It doesn't take as much time to set up. But you want to use a for loop anytime you know how many times you're iterating through, just because it's a better method, even if it's effectively the same. You want to use a while loop anytime you have something in here that's really complicated, or something that you can't count the number of times. You don't know how many times. For example, if you want to do a loop while mouse is pressed, right? Now you can't do this using a for loop, right? There would be no way to do this loop using a for loop, because for loop is only from 0 to x, right? So that's the difference. So here's a cool thing, is if we remove this I plus equals 1, and our challenge question at the bottom, instead of removing I plus equals 1, what if it was changed somehow? Why would I less than 10 be better than I does not equal 10? So let's see what happens when we remove this I plus equals 1. So let's set up our loop again while I is less than 10, and we're going to print out I, and then we don't have the I plus equals 1. So think in your head what you think might happen here, and when we play it, it prints out zeros infinitely. And that's because it prints out 0, then it checks, is 0 less than 10? Yes. Print out 0. Is 0 less than 10? Yes. And it just continues over and over and over again. Now we have a challenge question here. And the challenge question, like I said, gets you Ignite points. That gets you some kind of award at the end of all the lectures. What if it was... Sorry, I gotta move my mouse so it doesn't give us that thing at the bottom. What if it was changed somehow? Why would I less than 10 be better than I does not equal 10? So what we mean by that is if we change it to I does not equal 10, and I do I plus equals 1, let's think about this. The first time it goes through, it prints 0, it increments it up to 1, and then it checks, does 1 not equal 10? Yes, 1 does not equal 10. So this comes out to true, because 1 does not equal 10. So it goes through again. And it goes through 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when it gets to 10, it says, it compares and it checks 10 not equal to 10. And this is false, right? This statement is false. So the whole thing comes out to false, and we effectively get the same behavior. It goes from 0 to 10. Now the challenge question is, we have two options, right? Our first option was I less than 10. Our second option is I does not equal 10. Why is this version better than this version? Okay, that's the challenge question. First person to answer on Discord gets Ignite points. So try it out on your own computer. The hint we gave you was instead of removing I plus equals 1, what if it was changed somehow? Okay, so I plus equals 2. And why does that cause I less than 10 to be better than I does not equal 10? I'll give you guys a minute to play around with that and think about why that one's better. All right, it looks like we got an answer here. Hopefully the rest of you either saw the Discord or figured it out by yourselves. So the reason why this one is worse is because if we take this one, I does not equal 10. Let's say we incremented I by 2. Let's see what happens then. So now it skips 0, 2, 4, 6, 8. And then when it got to 8, it incremented 2 more to 10. And we still got this whole statement being false. So it works for plus equals 1. It works for plus equals 2. But what if we try something that doesn't hit 10 exactly, like 3? Because 3 goes 0, 3, 6, 9, and you see we never hit 10. And maybe if it gives us, I'll see if I can catch it again, but I think my computer's too laggy. If I run it, and then stop it. I don't think I got it, but if I caught it early enough, what you would see is 0, 3, 6, 9, 12. It never hit 10 because it's going up by 3s. Never hits 10, 12, 15, 18, 21, and it continues like that. So if we did I is less than 10, when we hit 9, it increments 3 more to 12. 12 still catches, is still caught by this statement, right? Because 12 is not less than 10, so this comes out to false. So if we use less than instead of is not equal to, we always get it caught no matter what, even if it's incrementing by a weird number like 3. Okay. So Let's talk more about how loops are useful, because that seems like a bit of a weird, loops seem kind of like a weird thing that we haven't really figured out a good use for them. So loops are great for repeating code and using multiple lists. We said that before, but it's kind of hard to come up with an example. So we'll do an example here to figure out how we can actually use lists and loops to save time. Let's use them to drag a few circles with different positions and sizes again. So this should be, to draw a few circles with different positions and sizes. So let's make a couple lists of sizes and positions. So we're going to have a list called sizes, and we're going to do the example that they gave us, and positions. So 100, 200, 300, 400. Now, if we wanted to print out a circle at each of these positions, which with each of these sizes, we would have to go circle, positions at 0, then our y-coordinate we're just going to say is 0 for now, and size would be sizes at 0. Print that out. Let's get a size going here for our background, and I have to indent all these. Ooh, I messed that up. It's supposed to be 300, not 3000. Size, we'll just do 1000 by 600. If we wanted to do this for each circle, we would have to do this 4 times, and I'd have to go through and manually change all of these to 1, 2, 3. And it seems like it's okay if we only have 4 circles to deal with to get them printed out like this. But what if I had 100 circles, or 1,000, or 10,000, or 1,000,000 circles that I needed to print out? I'm not going to copy and paste this 1,000,000 times and then go through and change each of these into the number that it's supposed to be. Instead, I get a loop where I have a variable I that goes through each of these numbers each time it goes through the loop, and then once it hits 3, it exits. Okay, so hopefully some of you can figure out what that would look like. I would want to do for I in range. How much do I want to give range? I want however many elements I have in my lists. So I have 1, 2, 3, 4. So I want a range of 4. And then in here, I can just put I instead of having to write out each of them. And then here, I'll just make this 200 so we can see the circles fully. So I forgot my colon here. And this is supposed to be indented. Perfect. Now we get the same effect, except it only took 2 lines of code instead of 4. And if I had 1,000 circles, I could go for I in range 1,000, and it would print out 1,000 circles. Now this wouldn't work here because I would need to add on 996 extra elements to these lists. But loops save a lot of extra coding. Obviously, you can also do this with a while loop. You would have to set it up the same way. I equals 0 while I is less than 4, and then I plus equals 1 on the end. So here's the first exercise, fancy squares. Use a while loop. Don't cheat and use a for loop like I did, to display 5 evenly spaced squares. Add another while loop to make the squares have different colors. We give you little hints here. The x positioned will depend on the loop counter. So the x position that you start drawing at the corner, that has some relation to the loop counter, which, if you remember in our while loops, I is less than something. We don't know what that something is. And here we have I plus equals 1. I is our loop counter. So when you print out, I guess in this case, when you print out your square, your x coordinate is going to be I times plus subtract divide. Divide is a slash, but it's going to be something to do with I, and then another number. Okay, and then you're going to have your y value as 200 and your size as whatever you want. But your x coordinate is going to have something to do with I, which is the loop counter. Okay, so I'll leave this up, and we'll give you guys about 10 minutes to figure out how to get evenly spaced squares. Alright, I think we're going to start up in about 20 more seconds here. Hopefully everybody figured it out or got as much done as they could. Just curious, if anybody did finish the exercise, do you want to throw a message into Discord or on the YouTube chat? If you figured it out, maybe mention if you got the colors to work as well. Nobody got it? Not a single person got it? I'm shocked. I'm sure some of you got it. You're just being too embarrassed to say something. Jamie M got it. Jamie M99. Awesome. So, we'll go through the answer really quick. It's actually not a lot of code. So we'll leave our size. So I said I was going to do it using a while loop. So while I is less than, this less than is actually going to be how many squares we want to print. So we have 1, 2, 3, 4, 5. So I'm going to make this less than 5. I'm going to leave my I plus equals 1 at the bottom. And what I'm going to do here is say I want to print a square at x value I times, I'm going to put a bunch of x's here for now because I'm not sure what I want to times it by. My y coordinate, let's just print them all out at 300. And what's my side length going to be? Here it looks like it's about, I don't know, 100. So we'll say it's 100. Now, I want to print them out. I want to print it at x value I times 100, so that it prints the first one out at 100, the second one out at 200, the third one out at 300, and so on. And I get them printed out like this. Now this is actually slightly different from the example. The example has some space in between each square. So the way I can fix that is I could print it at I times 100. Let's see what happens if I change this to 90. Now it's printing it out only 90 pixels, but it's printing it out 100 pixels ahead of the last one, if that makes any sense. And I get this little space in between because it prints it out at 0. It prints it out 90 pixels long. Then the next one gets printed at I, which is now 1 times 100, which is here, which is 10 pixels past where we ended. And I print 90 again. Then the next one gets printed at 200, right? 2 times 100, and it only prints 90. So now I'm only printing 90 pixels, but I'm skipping ahead 100 pixels. Now some of you might have done it slightly differently. You might have done it like this, where I is less than 500. You print it out at I, and you add 100 to I each time. This also works. I think this way is better for beginners. It's better for just sort of learning how loops work and things like that. But usually it's better to try and keep your I incrementing by 1 and then just manipulate the value in certain spots to get the value that you want. But obviously either work. They both produce a correct result. Now, last time we talked about this screensaver, and we said that you can do a better example with the screensaver. Now this is a more complicated screensaver. Last time we had a bunch of different circles bouncing around the screen independently, but you can sort of think about this as one solid shape. These 4 circles are stuck at this distance together, kind of like they're stuck together with wooden planks or something. And they're bouncing around kind of like a DVD logo, bouncing around a screen like that. This one's a lot more complicated. So we're going to do this using a loop. It would obviously have to be range 4 because we need to print out each of the 4 circles. Now, what we're going to do here is check to see if any of the circles have reached their boundary on the right side or the left side. And if they have reached that boundary, we need to change their velocity to be the other way. So for the horizontal velocity, x velocity, if it hits the right side or if it hits the left side, we want to flip the velocity to go the other way. Same thing for the y velocity. If it hits the bottom or if it hits the top, we need to flip the y velocity to go the other way. And we want to add the velocity to each of the y values and x values for each value in the list, and then draw an ellipse at each of those values in turn. Now the way that this works, the reason it's different from printing each of the balls independently is that it checks all 4 circles and it flips, sorry, I'm doing a bad job of explaining this. All 4 of these circles share one x velocity and one y velocity. All 4 of them share the same velocity, but we're checking all 4 of them to see this one hits, that one hits. We're checking all 4 of them to see if any of them have hit their boundaries. Because if one of these hits their boundaries, the velocity of all 4 changes. And then we want to print an ellipse. This is actually wrong. We actually want to do another for loop to print all four circles. So this bottom one, we want to have 4 of those to print each of those 4. Or sorry, this is inside the for loop up here. But this is slightly different from the screensaver where we have a bunch of independent circles. Now, inputs. This is where it gets cool. This is where we start using the keyboard inputs. Like if you want to make a game, obviously you want to use the arrow keys to move your guy, or the space bar to jump, or something like that. So we've already gone over this variable, mouse pressed. There's another variable called key pressed. Key pressed is true when any key on the keyboard has been pressed. Okay, so it's similar to mouse pressed. So a cool thing you can do with mouse pressed is if the mouse has been pressed, you slowly increment the color, the RGB values of the color. And the color will slowly increase from black up to white. And it has a blue color because we're incrementing blue the most. That's just how it happens to turn out. These all have to be global variables. There's another one called mouse button. Now, mouse pressed, the same way that key pressed checks if any key has been pressed, mouse pressed checks to see if either your left or your right mouse button has been pressed. So you could do a right click or a left click and you would get this color changing. But you can check what the mouse button is. So you want to check to see that there's a button pressed, and then you want to check to see what button that is. Is it the left button or is it the right button? And then you can have it do something different depending on which button you click. So let's try this super quick. We're going to do, we have to do this in def draw. So here I'll just do set up my size, and my background we'll do as a gray, and def draw. Now we'll do if mouse pressed and mouse button equals left. Okay, now if this happens, we want to fill it to be, we'll say black. I guess we'll do something fun. R, the first one's R, so we'll make it super red. And then the other one is else if mouse pressed, and we want to check to see if we did a right click, mouse button equals right. Then we want to fill with RG, so we're going to do fill with green. And then we want to use those fills to draw, we'll just do a circle. Somewhere on the screen, say 500, 300, with a radius of 100. And if we run this, this should be 1,000. And if we run this, that's a left click, right click, left click, right click, left click, right click, and I can just click my mouse a bunch of times to have it change between red and green. Now you can do a bunch of other things with this. You can make these variables called draw circle and draw square. You could have it change between drawing a circle and drawing a square, kind of the same way we did before. If key pressed and not draw circle, then you change it, and if it's not draw square, then you change it to draw square. And you can get a bunch of cool things like this happening. Now key is sort of the equivalent of mouse button. So we have mouse pressed and key pressed to check if any of them have been pressed. Mouse button checks whether it's left or right. Key checks which key was pressed. And the way you check it is actually just by the value of the key. So you check to see if key equals quotes A, and if you were pressing the A key on your keyboard, this would come back as true. And that lets you do a whole bunch of different things. So let's try this example. This is using text on our draw, our little draw pad. So if we copy this, text size, text align, text size, we'll do 32, text align, center, and all right. So we're going to check if we want to check to see if we got a key pressed, and we want to check if key does not equal space. Now you notice in here, obviously I just put a space. I just hit the space bar to put it in there, and it checks to see whether the key was a space or not. Then, what do we want to do? We want to print out text with the key on it. Text, now we'll just put the key, so for example, this key, if I hit A, this will print out the letter A for us. And we'll print it out 500, 500. So let's just try this. Now you notice I wrote this code slightly differently from the slides. I checked to see if key was pressed, whereas this one doesn't check to see what key pressed is. And we'll see how that makes a difference. So if I click A right now, I get A printed out here. But if I let go of A, ooh, I gotta draw my background every time. Background, we did 70, 70, 70 at the top. So if I click A now, I get A on here, but if I let go, it disappears because key pressed is no longer true when I'm not holding it. But if I get rid of that, it just prints whatever the last key that was pressed, whether or not it's currently being pressed. So key kind of remembers what the last key you pressed was. It doesn't know if you're currently pressing it or not, but A, and then I let go of it, and it stays there. And now I click S, and I can do anything that I want. But it always stays there, even if I just give it a tap. I'm just tapping it right now. Okay, now the reason that we do this is not equal to space is we want to do a special case for the space bar. If key is equal to space, we want to do the same thing, except we want to do something to tell us that the space bar was clicked. Now the reason that we do that is obviously because if we printed out the key value for spacebar, like if we actually do that, if we just print out the key value, we wouldn't get anything printed out because the key value for space is empty. So this is just a little thing to get spacebar to actually understand, to actually be able to see that our spacebar is working. Now we have a little bit of a challenge question here. So the challenge question is, how can you make it so that when you click, you have it the same as we have here, except if you were to click number 1, okay, instead of getting a 1 to print out here, you get a number 1 to print out. Okay, so then on the screen you would get 2, 3, 4, 5, 6, 2, but then when you hit 1, you get a hashtag 1. Okay, now one way you could do it is you could try and put like a hashtag in front of each key, but then you would get a hashtag printed in front of every key. So how could you get a hashtag to print only in front of 1? Okay, so what I meant by that was you could do text and do a hashtag 500, 500, but then you're getting a hashtag printed in front of everyone. Well, this is right on top of it. I guess you would want to make this slightly different so that it gets printed in front of it. But the challenge question, who can get #1 to be printed out, but have all of the other numbers print out normally? Okay. Who can answer it first? I'll give you a few minutes. If you have the answer, throw it in the Discord and tell us how. Alright, so it looks like nobody threw an answer in the chat. Maybe that's because it's so easy, or maybe it's because it's too hard. But we'll just go over the solution right now. So we want to get a hashtag to get printed out in front of a 1, but not in front of every other one. Well, let's first try and figure out how we can get a 1 to print out in front of every letter. Well, I almost had it here, except I want to move it back slightly so that it's actually printed out in front of it. So we'll move the x-coordinate back a little bit, and now we get an x-coordinate printed out in front of each one. Our hashtag printed out in front of each one. Now, I only want this to be printed out if it's a 1. So, once I know that it's not a spacebar, then I'm going to check if key equals 1. If that's true, I'll print out a hashtag, and then I'll always print out the key value. So if it's not a 1, it skips this and just prints out the key. If it is a 1, it prints a hashtag and then prints out the key, which we know is a 1. So if I go A, B, C, D, E, F, 4, 3, 2, and then when we print 1, we get that hashtag printing out in front. So we'll continue on. We're almost at the challenge question at the end. So now we have coded and key codes. So these are a little bit different. A value that is key is set to, a value that key is set to when the key is pressed that is not a letter or a number. So for example, you see if I click 1, 2, 3, 4, 5, you notice that they print out normally, but let's say I hit shift. Shift, that I promise I just hit shift and it comes out as 65,535. Or if I hit caps lock doesn't even show up. Caps lock, see, caps lock actually comes out the same thing as shift. If I hit enter, it just completely disappears. If I hit the arrow keys, I get this 65,535 thing again. So there's no way to represent arrow keys or a shift or enter or caps lock or tab or any of those weird keys. So key code is our way to check for those. Now, it's kind of complicated to check for this stuff, but you have to check to see if it's a coded value, and if it is, then you check the other variable called key code. Key code equals up. Okay, so if we want to fix our code here so that it works with, for example, the arrow keys, we'll get rid of this because we don't care about the space bar not working. So we're going to check to see if key equals coded. Okay, now if key equals coded, we're going to check if key code equals up. And this represents the up arrow key. Then we're going to print out text. How do we want to represent up? We'll just say up. And we'll print it out. I'll get it more in the center of the screen. So 300. We'll do another key. So we'll say if key code equals down, text down 500, 300. That's good for key codes. Now, if key does not equal coded, that means that it's a normal key, like a letter or a number. So we could say else, because we know if it's not equal to coded, then we know it's a normal key. Else, we can just print out whatever the key is. And we don't have to worry about it being a shift or a control or a tab, because those would have been caught by this if statement here. And if we run this, 1, 2, 3, 4, 5, 6, up, down, and then if I hit control or shift, those obviously don't work because we didn't set them up here. If I hit shift, now see, when I hit shift, I'm not getting that weird 65535 because it's not trying to print shift as a key. When we hit shift, it goes into this if statement, and then there's no other if statement to catch it, so it just does nothing. If we wanted to add shift in here, we would just add 1. I'm not actually sure. Maybe shift actually detects the shift button. Yes, it does. And then maybe tab might be tab. It looks like it because it turns green. And then, I don't know, caps lock. It looks like caps lock might be a different keyword, but you get the idea. Now, I think that's our last slide. Ooh, yeah, this is cool. So now we can sort of use our arrow keys to control a ball. I won't do this because we want to move on to the challenge question, but you would have this inside your draw, and if you click the up button, check if it's coded, and then check if the code is up, then you move the ball up 5. And if it's down, you move the ball down 5, left, you move it left 5, right, you move it right 5. And now you've got this little ball on the screen that you're not controlling with your mouse, you're controlling it with your keyboard. And this is essentially the start of games that we can start to code, where you control a little guy on the screen and you can move him around. But for now, let's finish with this last exercise. So when the mouse is pressed, make all the balls follow the mouse like this. And then when the mouse isn't pressed, you just have the circles continue to float on whatever trajectory they had. Okay, so we're actually going to be doing pair programming with this because this exercise is so complicated. So if I can get everybody to check on Discord, somebody is going to post instructions for how to do pair programming, and we're going to match you up with another student and a mentor and get you guys coding on this. So if everybody can go over to the Discord chat and check general, there's going to be instructions posted on how to do this. And the answers, the solution to this will be shared on Google Drive later on. But for now, we want you guys to try and do this yourselves. Okay, so head over to Discord and we'll have the rest of the instructions over there.